Hello everyone, welcome to this exciting tutorial on sentiment analysis with BERT. So today we are going to deep dive into using the BERT to analyze the sentiment of text data and visualizing those results in a really cool way. So stay tuned, and not only that, throughout this video I'll be sharing a key interview questions related to sentiment analysis and BERT. So stay tuned to make sure you are prepared for your next data science interview. So now the first thing for the building sentiment analysis model is we have to load the pre-trained bot model and also tokenizer, right? So now we are just going to load the pre-trained model. I have code ready. I'll directly copy paste. So this is the things. So what we did basically, as I'm going to use PyTorch, right? So I'm just importing the torch, and here I have just imported the BERT tokenizer which will be used for tokenizing the model, and we have also used and I have imported the BERT for sequence classification. So this BERT for sequence classification is nothing but it will be used for classifying our text, right? So now this is the model name which we are going to use, and I have loaded the tokenizer. I have also loaded the model over here. Now, moving to the next step. So now it's time to answer our first interview question. What is BERT and why it is useful for sentiment analysis? So BERT is basically bidirectional encoder representation from transform. It's a transformer model that captures the context of each words in a sentence, making it especially good for understanding nuances in a sentence, right? So our next step is to tokenize the input text and run it through the and pass it through the basically BERT model and get into sentiment prediction, right? So I'll directly copy paste the code and I'll explain what is happening over here, right? So see what happened basically. Now we are basically using this tokenizer. So we are passing the text to it and we are asking it to return in PyTorch format, right? Return the tensors in PyTorch format, and we are also using truncation is true. So what this truncation does is at the BERT has context limit. It has maximum context limit of 512. So if the text token limit will exceed more than 512, it will basically truncate it. Kind of, it's like remove it. It will remove it. And if it is less than 512, it will just do the padding over here, right? So that will be that is the use of max limit. Now the next thing what we are doing, we are just trying to get the we are passing the input to the model and we are trying to get the logics, right? And one more thing to take care of here is we are using toss.no grid. So basically this no grid is nothing but we don't want to perform any gradient operation because it's the prediction, right? We are directly doing the testing, we are not doing the training of the model. So when we do the training we need gradient, right? But as we are directly doing the prediction, so we don't need gradient. So now that we got the logics, what we need to do, we just pass it to the softmax function, right? So this, once you pass this logic to the softmax function, we'll get the probabilities of each of the sentiment labels. So basically it will give us the values, right? So and that value, each value will indicate how much probability of happening very negative, how much probability of happening negative, each of this class, right? And then we are just trying to print out the probability value. So now it's time to test our sentiment analysis function, right? So let's just test on some of the text by passing some of the text. So let me directly pass some of the text over here, right? So see, we are passing these five texts basically, and we are just wanted to know what is the sentiment of all of these texts, right? So see how what the model is basically giving. It is first tokenizing the input, right? And then what is happening passed into the BERT model. And then we are applying the softmax over that outcome, which we are getting the logics, and finally we are getting the probability of each. So if you look at one thing, the softmax give us the probability which add up to 1. If you add all the values, it become 1, right? So now it is saying that, so which one has maximum probability? So basically very positive. So with that we can say this first sentence belongs to the very positive. Similarly for the second sentence and third, right? So for all of the sentence we got what is the sentiment. So now it's time for us to visualize our text. So using t-SNE. So basically t-SNE is a powerful dimensionality reduction technique that helps to visualize high dimensional data in a lower dimensional space, right? So some of the interviewer might ask you questions, right, related to t-SNE. They might say, how does t-SNE help in visualizing high dimensionality data like BERT embedding, right? So what you can say basically, t-SNE project high dimensionality data into 2 or 3 dimensions, right? And helping us to visualize and understand the relationship between different data points by clustering them. So let's do the visualization now. It's fine, right? We just got the embeddings, we got the labels, which is the same as previous steps. So now uh, here we are just passing those embeddings because these embeddings are the one which we want to visualize by reducing to the lower space, right? So we also checking what is the length of this space, basically embeddings, right? And we need to make sure perplexity value, right, should be minimum of either 30 or that n sample minus 1, or else it will give us the error. So we are just initializing the t-SNE and we are passing our embeddings, right, multi-dimensional embedding basically to this t-SNE to convert it for 2 dimensional. So once it got converted, we just need to visualize it, right? So what I can do now, I'll just do the function call for this in order to visualize it. So let's see how it looks, right? So if you look at it, right, these all steps are same. So see what happened basically. It has reduces the dimensionality of our embeddings to 2 dimension, and now we can clearly see where exactly our data points lies in this 2 dimensional space. So if you have more number of data points, then in that case it will be very clearly visible that these all data points are within very similar or within a clusters kind of. Okay. So this comes to the end of this video. I hope you understood how we can do sentiment analysis using BERT model and how we can also visualize our embeddings using these and also some of the interview questions which people might ask related to sentiment analysis, right? If you enjoyed this video, don't forget to like, subscribe and share with others interested in data science. Happy learning.